So we have Joe Carroll is here, and
Dave is outside, and as is Paul Davies, and I think there are people out trying to find him.
all right. So we have an all-point bulletin for Paul Davies, for Robert Pappalardo, for Davin Newman, for Shannon from Hewlett-Packard, and anyone else who was speaking here this morning. I may be missing someone. All right, but in the meantime, I'm going to interact with you. Okay. All right. So I don't know if you know, but at Martin Marietta Company in the 1960s, work was done on artificial gravity. And they tested with human subjects hypergravity, but nevertheless various rates of rotation on Earth from 1 RPM to 6 RPM. And what was found was that 1 RPM created no noticeable Coriolis effects. With 2 RPM, it was mild but noticeable. With 4 RPM, it was very noticeable but readily adaptable within hours. And with 6 RPM, it was eventually adaptable. So I definitely think the 2 RPM is quite a doable thing, that we don't have to be at sub-RPM numbers. Okay, Paul, thank you. Have a chair. What we're trying to do is put together a panel where people will have a chance to answer questions, especially in view of the fact that our 11:30 speaker dropped out, and I want to keep the show going until 12. All right. Okay, Dr. Pappalardo is here. So anyway, that's my question to you. But after that, let's have audience questions to any member of the panel.
Okay. John Charles was the person who brought up to me the uncertainty of the relevance of the ground-based rotating room tests to the artificial gravity. And, that question mark that I showed on the second, my third slide, also applies to rotation rate as well as to gravity level effects. And it is quite possible, and I think it would be great if we can adapt. But it's not clear to me. I mean, there's several distinctions. One is the threshold for conscious detection of an effect and the threshold for negative feelings that you don't feel good but you don't know why. It's not clear which is higher, okay? It is known that zero-G adaptation is different from seasickness, but it is also known that for both effects, they're highly variable from person to person. And so one of the things is you don't want to set up an experience, especially a commercial experience, that people pay for and then find out they don't like.
You mean like cruise ships?
At any rate, it is unknown, and I'd like to know.
Okay, well, certainly knowing is good. But I'd like to open this up to questions because several of the speakers here did not have any time for questions. So questions for any of the panelists.
Hi there. My name is Jeff Purnell with Galactic Farms. I'm curious, this is a question for Joe. There's the German Aerospace Center's satellite that's going up. I believe it's called the EU CROP-IS or CROP-IS. Are you familiar with that one, and can you speak to that as far as simulating gravity of Moon and Mars?
I know the Europeans have a microbiology centrifuge on the space station. I don't know what they've done with it, and I don't know I haven't been following experiments recently as to what's being done. I was disappointed that the larger centrifuge never got launched, the one that NASA built and then gave to the Japanese but never launched. Rotation rate is one thing for mice. It's another thing for human beings. We're more interested in human beings, but there are things we can learn from smaller animals, and there are things we can learn from crops. And we know we can grow under certain conditions crops even in zero-G. What the effects are, I'm not a biologist, okay? I'm somebody who got interested in the artificial gravity and partial gravity and have been gradually learning about different aspects of it.
Other questions? Sir.
Okay, I've got two questions. First about Europa. The ocean underneath, is it an H2O ocean like Earth? Okay. And for you, Robert, on the Nat Geo series, a great television show, a great movie, a great book, as you're experiencing it, the thought goes through your mind, oh my gosh, that's the way it really is. When you were watching the final product, you know, the 6-part series, how did you feel? Were you picking apart a lot of inaccuracies, or were you basically satisfied with the accuracy of the series?
Well, overall, I was satisfied with the accuracy of the series. And also this is true of The Martian, which is that while as an engineer you could go through these things and identify flaws, the spirit of both of these was realism as opposed to fantasy, which is the key thing. And also the spirit of both of them was not, I mean, most previous Mars movies, I wouldn't even call them Mars movies, they were basically either shoot-'em-up Sahara pictures. They were not about the actual challenge of human exploration or settlement of Mars, which both of these, well, The Martian was about exploration, the other one was about settlement, but they were. So what we're starting to see here is actual attempts by serious players in the theatrical world to address the question of the human exploration and settlement of Mars. In other words, this is really moving into the zeitgeist, the mind of the times, as something that we should be thinking about, and people are starting to think about it. And I think that, therefore, both of these pieces of art were quite productive and helpful. So yes, I liked it.
And back to Europa, the ocean is indeed salty water, and we don't know how salty, whether it is. Thank you. So we don't know how salty it is, and that's something we can find out with the follow-up mission, because we'll be there longer, making more flybys. We can actually get at the thickness and salinity of that ocean.
Okay, other questions? Sir, can someone bring this gentleman a microphone? Oh, someone else has got it? If someone's got it, stand up and speak.
Yeah, has anybody looked into perhaps a spinning a bedroom for humans on low-gravity environments, kind of like the Great Mambo Chicken?
Doug Plata, who has talked several times here, has looked at, you know, spending part-time in a very small centrifuge where you can sit and do sedentary stuff, but you don't want to turn your head, okay? At the Alabama Space and Rocket Center, they've got a ride, and I did all the things they told me not to, and didn't bother me then, but the next 2 hours I felt queasy. But yeah, there are all sorts of candidates for fixes, but the simple story is that after 50 years, we're still looking for a better solution for the problems imposed by microgravity. Now, if NASA advertised this problem a bit more, there'd be congressmen that don't have NASA facilities in their states saying, well, I know how to solve this problem, just bring them all home. Okay, we don't want that solution. So I can understand NASA's probably having severe heartburn when Packing for Mars came out, Mary Roach's book, which is a fun read and a very good overview of the issues of living in microgravity, in vacuum, et cetera.
Okay, other questions? We have one over here.
Hi, my question is for Joe also. I'm an outsider to the engineering world, but I often hear from it about the need for redundancy. So I was curious, what happens if the tether malfunctions, something hits it? What do we do in that scenario?
I have a detailed paper that's the bibliography to my presentation, which, did you get it? Well, I sent it to to Jay Burke at Mars Society. You got it. Okay, so it's going to be, is available now to anybody that wants it down? Okay. The last page of my presentation is a bibliography, and one of the items is a paper that I wrote that you can download, and I go into detail on lots of operational issues, including tether failure, okay? And it's ugly, but it has to be made survivable. And there are a variety of constraints on the design associated with that. Now, since I wrote that, there are another several ingredients in the possible solution for the problem, and I think it is feasible to track most lethal debris in low Earth orbit. That takes it down to like 5 to 7 millimeters, and do so and predict collisions accurately enough that it's actually affordable to miss them, okay? It's called actionable avoidance. That could change things, but you still have the possibility of the North Koreans decide they want to ruin your day. And so even, you know, and you want to be able to survive that. You want to be able to make that day not be as bad as they want it to be.
Right here. Microphone.
Would the sulfur smokers and sulfur bacteria metabolism in the smokers in the bottom of the ocean satisfy your search for a different form of life? And if not, can you have some ideas of what you will be looking for?
So first of all, is this on? It's not on. No, all of the microorganisms returned from the deep ocean volcanic vents that have had their genome sequenced are all firmly on our known tree of life, so they're not candidates. The point I was trying to make is that, you know, how would we know if there is a subpopulation of those, for example, that were life but not as we know it? And the difficulty then is you try to get a genome sequence, it wouldn't work. And so we could easily have overlooked a subpopulation of exotic or weird life in that location. So what we did in the paper that came out of the workshop was to distinguish two scenarios. One is where this weird life is beyond the reach of life as we know it, terrestrial life, known terrestrial life. And by that I mean that within the parameters that known life occupies, so temperature being an obvious one, pH, salinity, radiation, all of these define some high dimensional parameter space that can accommodate life that we know. If we go looking outside of that and find something living, it would stand out. And the deep ocean vents are the easiest example to imagine. So life as we know it, the temperature record I think is 123, the official record. If there was nothing growing between 123 and say 150, and then suddenly something from 150 to 160, that would stand out. It's isolated in the temperature parameter, and then you want to take a careful look at that. Much harder would be if this weird life likes the same conditions as known life, so it's intermingled. And then untangling the two, you would have to resort to the type of experiment I was talking about. That is, you find some culture medium that is lethal to all known life, but if there's anything that lives on, then that's a candidate for life as we don't know it. But it's actually a big challenge to know how to separate the sheep from the goats, so to speak.
Gentlemen, there's a medical solution to the loss of muscle mass instead of a technical one. Myostatin is a hormone that causes muscles to start to break down after 72 hours of disuse. Myostatin can be blocked, and scientists have actually created a vaccine where they can inject, I'll volunteer to be the first person, with this vaccine, and you gain about 20% muscle mass and you maintain it without exercise.
And Schwarzenegger doesn't know about it?
Actually, people like Schwarzenegger have a naturally low level of myostatin, and there's a few children in Germany that they found who basically have no myostatin, and the 6-year-old can hold out a 20-pound dumbbell like this and sit there with it. So it's the cattle, the giant cattle with the huge musculature. That's how they discovered this, because as they bred them for more and more muscles, they found some so muscled they'd fall over. They had basically bred out their myostatin gene. But myostatin is what our ancestors survived when there wasn't enough food around, probably why Neanderthals are gone. They may not have had it. But anyway, if you inhibit myostatin, you can maintain your muscle mass. It doesn't help with the eye problems and other stuff, and you still have to do your cardiovascular exercise. but you would not have muscle atrophy.
Well, that's something that if it's known and if it's safe, it's probably been tried, and either it's part of the standard recipe for what we think we want to do for countermeasures or not. I don't know. But if it's known, there's a serious research community looking for medical solutions, because they want medical solutions, I think, way more than they should. And I think it's partly having to do with this: if microgravity is a problem, bring them home. And we don't want that solution. NASA doesn't want that solution.
There are several problems that we absolutely know about in traveling in zero gravity to Mars, and there's a school of people that say, let's just take the risks and travel there. If we get to Mars and we have people there, going further, maybe we mentioned about going to Europa, the spacecraft have a problem there because of the radiation. Will we be stuck to the inner solar system, or do you think we will just lower the barrier of human safety to go further, or wait for the tech to catch up so it's, again, 100% or as close to 100% safe as possible?
I think we will end up learning a lot by going to the easy places, and that may help us get to the harder places. But we're not going to go every place all at once. And I mean, the people that settled the West, they were perhaps mostly adventurous, but I'm sure that some of them were leaving huge debts behind. They were leaving a bad marriage with an informal form of divorce. People may try to go somewhere that it's very imprudent to go just because nobody else is doing it. And they may survive, they may not.
To follow up on your talk about Europa, which was really fascinating, what's your vision when you say we're checking if it's habitable? What would it look like to at some point live on Europa? In particular, you talk about the spacecraft can't even come in very often because of the high radiation. What would it be like for people to live there? Thanks.
Yeah, so of course we're going after microorganisms, right? Or first habitability, and then a lander would go after microorganisms. But if we think about the distant future, remember that just about a meter of ice will stop the radiation. So if we were to tunnel or bury in a meter of ice, that's sufficient to stop the radiation. So while the first notion that comes to mind is, oh, never, that's impossible, so many things that were impossible are now possible. So it's conceivable if the biggest issue would be launching lots of mass to get there, because we're deep in Jupiter's gravity well, and then dealing with the radiation environment with some sort of artificial structures.
Does someone give this gentleman, over there, I see.
Okay. For Professor Davies, last night someone wondered why we don't have a concept of panovia that corresponds to the panspermia idea, and actually there might be something to it, because the population of Earth and all the environment there contains a lot more genetic information than is ever in use. So I wonder if you would agree with the idea that there might be a sort of a key and lock sort of process that goes on, that some factor arrives from space and activates a new species, and something like that could explain the Cambrian explosion and other sudden appearances of species out of seemingly nowhere.
Yeah, well, you raise a lot of issues, and Bob Zubrin has addressed some of those in his paper that just got published. But the one thing that I would like to say is, because I was talking about this shadow biosphere idea, so I've speculated, I suppose most recently in my book, The Eerie Silence, about how would we know if there was alien technology in the solar system, not now, but any time during the history of our planet, because if aliens were interested in coming here, they could have come at any time. They don't need us to be around to invite them in. And so if we take a figure like 100 million years ago, how would we know if there was alien technology in the solar system 100 years ago, 100 million years ago? And there are three things that would endure, it seems to me. One of these is nuclear waste. If there was anything dumped, we could still find traces of that and figure out when it was dumped. The other would be large-scale quarrying or geoengineering projects, because that would still, like the Chicxulub crater, you can't see it, but it's there in geological surveys from the dinosaur impact. But the third one is biotech, that supposing they had created a shadow biosphere for their own purposes, maybe industrial purposes, food purposes, experimental purposes, that would coexist with our biosphere. Then we could discover that today. That would be a shadow biosphere, actually engineered by some alien technology, not necessarily the beings themselves, but their instruments that would be sent. So it's easier for me to imagine an alien species, an alien technology creating their own biosphere ab initio than somehow uploading stuff into ours. But who knows? I just made this general point, then I'll be quiet. The idea of uploading information into terrestrial genomes might seem very fanciful, but Craig Venter did it. His email address is apparently in, what is it called, Mycoplasma Laboratorium. And so this is now standard technology. So we can do it. We can upload information into terrestrial genomes. Maybe ET can do it as well, or maybe the truth is within us. And all we need to do is just write the algorithm to decode the message. That's exactly retroviruses.
Part of the genome that we haven't been able to read might say, E.T., if you evolve far enough to read this, please call home.
Right.
Is that what your paper was about?
No, it's got a lot more in it. You'll have to, you'll have to read it. We're going to have to close it soon, but I want to close by posing another question to Paul Davies. Because in your talk, you said that this this observation that life appeared on Earth very quickly within a couple of 100 million years after it could, that some people, Carl Sagan has argued, many other people argued that this shows that life is probable and it appears everywhere in the universe and that it can. And you said, well, no, we can't accept that. But I would like to take you up on that because, okay, let's say it appeared 250 million years. The naive opinion then is that that's a typical time that it appears. And you say, no, maybe we were just lucky, and the typical time is 1 billion years. Okay.
Much longer, yes.
Okay, let's take a simpler example. 500 million years, twice as long. Okay, that would mean that there was only a one. In other words, if 500 million years is the half time for when life appears, the sort of the half-life of the improbability of life. Okay, that means that we appeared in half of that, and therefore there was only a 25% chance that life could have appeared when it did on Earth. And if you say the half time was 1 billion years, then there was only a 12% chance that life could have appeared on Earth. So the longer you set that time, the less probable your theory is. Okay, so in other words, the theory that life takes a longer and longer time to typically appear becomes increasingly improbable as you multiply it times the amount of time it took life to appear on Earth.
Right. The Carter's argument only works if the time required for the hard steps, not just one, but maybe several, leading up to beings like ourselves, is very much longer than that window, so trillion years or something. And then it's a simple mathematical argument. You're in the tail of the exponential and you get his formula. He says that it would be an extraordinary coincidence if the emergence time for life happened to coincide with the lifetime of a typical star, because these are disconnected processes, and therefore it's likely to be very much less than or very much greater than.
But most stars live much longer than our sun.
Well, but a factor 10 or something. And we're talking here about much, much bigger factors. So he's saying that if the probability of life starting on an Earth-like planet, you know, if the expectation time is, say, 1 trillion years, then you get the rapid appearance.
But if the expectation time is 1 trillion years, then we couldn't have happened.
No, because we happen against the odds.
All right. Well,
so there's a sequence of. So,
all right,
so
but then
this
his
the great
theory is
filter
against
argument.
the odds.
No, it's exactly symmetric with the high probability. It's mathematically exactly the same probability of the theory being true if it's a rapid appearance or if it's a very unrapid appearance. What would be extremely unlikely would be the case that you gave where the numbers happen to match within a factor of 10 or
All right.
something.
Well, we'll have to continue this later. Thanks to all of you. Okay.